At the end of the last video, we found out how to do practical calculations using logarithms. We started off with the truly brain-bending 10 times 100 equals 1,000, and then moved on to 2 times 3 equals 6. Then we had this jarring segue into saying we would understand where this equation comes from, that the log of a to the power of x equals x log a. To do this, we need to do a few more calculations. We need to go back to our original calculations using log tables, and we would take a number and we'd find the log of that number, write it down. Then we'd find our next number, find the log, write it down, and the sum of these two numbers became the log of the answer. We'll take a simple example of 5 times 5. And that's very obviously going to be 5 squared. In order to do this calculation using logarithms, we follow the same pattern. First of all, we find the logarithm of the first number, which in this case is going to be log 5. Then we find the logarithm of the second number, which is going to be log 5. As it's a multiplication, we add the logarithms together, and that gives us the log of the answer, which is going to be log 5 plus log 5. It's going to be 2 lots of log 5. We'll do another calculation. We'll make this one just a little bit more complicated. We'll use 7 times 7 times 7, and that's going to give us 7 to the power of 3. We'll take the logs of both sides, and that's going to give me the log of 7, and the next number will obviously be log of 7. The next number will obviously be the log of 7. As it's a multiplication, we add them together, and that will give me once, twice, 3 times the log of 7. One of Lionel Richie's less memorable hits. And the final calculation we're going to do is going to be the most complicated of them all. We're going to do 3 times 3 times 3 times 3, and that's going to equal 3 to the power of 1, 2, 3, 4. And just for an extra frisson, we're going to use the natural log in this case. We find the log of the first number. It's a multiplication, so we know we're going to add the log of the second number, add the log of the third number, and finally add the log of the fourth number. And that's going to give me 1, 2, 3, 4 lots of log 3. With the intervention of a little video magic, a little writing error has been corrected, and some blue lines have appeared to separate out the calculations. Let's go back. Our first calculation was 5 times 5, gave us 5 squared. And I promised you that we would understand where this mysterious a to the power of x, when you take the logarithm, gives x log a. Look at what we've got. We have got here a number base raised to a particular power, and here we have got a number base raised to a particular power. When we took the log, that became power multiplied by the log of the number base. And over here we have taken the log of a to the power of x, and when we do that we get the power multiplied by the log of the number base. So this is this, and this is this. Let's look at our next example. This had 3 numbers in it, so we had 7 to the power of 3. But again, it follows the pattern. In this case, we'll call it b to the power of y. We took the log, and we got a result down here, which was the power multiplied at the start, which is the power here, multiplied by the log of the number base. Which is identical to the pattern log a to the x equals x log a, log b to the y equals y log b. Our final example was the most complicated example. We had 3 multiplied by itself 4 times, which gave us 3 to the power of 4, and we used the natural log. Nonetheless, it follows the pattern. We have c to the power of z, c to the power of z. We took the log of that, and 3 to the power of 4 became 4 log 3. And over here we have the power z all we're doing with this mysterious equation, the log of a to the power of x equals x log a, is nothing more than a numerical calculation, but we're using symbols rather than actual numbers. Here 5 times 5 becomes 5 squared. We take the log of 5 squared and we get 2 lots of log 5. Here we took 3 lots of 7 multiplied together, and the answer became 3 times the log of 7. Here we had 4 lots of 3, and the answer became 4 times the log of 3. This then is the big reveal. Our equation that the log of a to the power of x equals x times the log of a is nothing more than using log tables, but using symbols instead of numbers. And we've used fractional logarithms. The same is true if this power here is fractional. If I wrote out 5 to the power of 2.7 and then found the natural log of that, the answer would be 2.7 times the natural log of 5. Nothing changes. If I had 6 to the power of minus 2, which would be 1 over 6 squared, and I took the natural log of that, the answer would become minus 2 times the natural log of 6. And obviously if I want to work out a numerical answer, in this case it would be e to the power of that. So the answer would be e to the power of 2.7 log 5. Here the answer would be e to the power of minus 2 log 6. And that's really all there is to it. Thank you for watching.